presentation is CTCs, our body's hidden gems. Now first let me tell you a little bit about myself. I'm a senior undergraduate biomedical researcher. My dream in life is to become a physician, specifically a surgical pathologist. Studying cancer is really important to me because I have personally seen the destruction that cancer can cause in the person diagnosed as well as their family, especially since my dad was diagnosed with skin cancer when I was in the 7th grade. Now I'm here today to discuss and communicate with all of you a research project that explored that the key to our success in furthering pancreatic cancer diagnosis and staging could be found within our very own bodies. Throughout my talk today, I'm going to discuss what the research project was about, how they did it, what their experimental design was, what the results were, and why the results are important and should be important to all of us in this room today. Now, I'm sure you all are aware that the pancreas is located very deep within the abdomen, making it hard to locate and diagnose pancreatic cancer accurately. It's also very hard to stage pancreatic cancer because the common techniques for staging, which are CT scans and MRIs, cannot pick up this type of cancer accurately. So that leads to the two main questions that this research project was exploring. Is there a better way for us to help, or is there a better way to diagnose and stage pancreatic cancer without invasive techniques like surgery? Can we use a biomarker, which is a measurable substance located in the body that can indicate a disease or illness? Can we use a biomarker instead to help aid in diagnosing pancreatic cancer? So just for review, there's 4 stages of cancer. Stage 1 is where there's a small tumor presence with no lymph node involvement. Stage 2 is where the tumor is slightly larger but still no lymph node involvement. Stage 3 is there's a tumor presence and lymph node involvement. And stage 4 is metastatic pancreatic cancer, or metastatic cancer, which means that the cancer is spread outside of the organ. In 2016, Dr. Mark Gerges, along with other researchers and scientists at UCLA, explored the idea that maybe there is something in our body that can help diagnose pancreatic cancer. They decided to look at circulating tumor cells, or CTCs. CTCs are cells that break off of a primary tumor, travel throughout the body looking for a new home, and to settle in, also known as metastasis. They hypothesized that the amount of CTCs located in the body or throughout the blood could indicate or correlate what stage of cancer, pancreatic cancer, was at in each patient. So in order to do that, they had to separate CTCs from everything else in the blood of each patient of the trial. So your first question is, how on earth do you separate a CTC from everything else? Well, they use a nano-Velcro chip. And your follow-up question is most likely, what on earth is a nano-Velcro chip? So I have a visual right here to help explain what a nano-Velcro chip does. So they first took 4 milliliters of blood from every single patient. In this black board right here, this is my nano-Velcro chip. On the black board, there's white strips, which I'll show you when I display the board. These white strips are nanowires. The nanowires are 1,000th the width of one of your human hairs, so they are teeny tiny, and they are covered with antibodies. Antibodies are just a protein that are specific to the CTCs, or circulating tumor cells, so that when they run the patient's blood over the nano-Velcro chip, the CTCs will stick to the antibodies like Velcro, hence the name nano-Velcro chip. So these purple balls, purple for pancreatic cancer. These purple balls are CTCs, and these pink or orange balls are everything else, like white blood cells, red blood cells that are located in the blood. So as the imaginary blood runs over the nano-Velcro chip, the CTCs stick to the nanochip. So after they completed the experiment and they collected all the CTCs onto the nano-Velcro chip, they counted them up. And after they counted them up, they correlated that to the staging. And they found as the amount of CTCs increased, the staging of the pancreatic cancer progressed or got worse. For example, in stage 4 metastatic pancreatic cancer, there was the highest amount of CTCs. The study also found that through various statistical analysis, that the amount of circulating tumor cells in stage 4 cancer was statistically significantly different than the amount of CTCs in stages 1 through 3. Now, statistically significantly different is a fancy word for they did a bunch of probability tests, and the results produced are reliable and can be trusted. That means that CTCs can be a useful biomarker in staging and diagnosing pancreatic cancer. Now, that's a lot of information that I threw at you guys, so there are 3 things that I'd like you to take from this discussion. The first one is that the location of the pancreas makes it very difficult to stage and locate pancreatic cancer. The second thing is that circulating tumor cells are cells that break off of a primary tumor and travel the body looking for a new home or metastasize. The third one is that CTCs can be used as a biomarker in order to help aid in diagnosing and staging pancreatic cancer. All of us in this room know somebody that has been diagnosed with cancer or have been diagnosed themselves. By finding new techniques to stage and diagnose pancreatic cancer, we can minimize the amount of intense chemotherapy, radiation, and surgery. If you'd like more information or access to this article, you can find it on the British Journal of Cancer website, or you can actually feel free to contact me. My email is the one on the top right here. And my last note for all of you is that we are all a family in this room together. We will fight this battle as one, and we will get through it together. Are there any questions? All right, thank you.